Hi everyone, in this video we are starting the new topic which is topic 4.2 loans, investment and annuities. So this topic is sometimes called as financial mathematics as well because it's just basically about how are we going to apply mathematical knowledge into a financial situation. Okay, so before we looking at today's learning outcome, I would like to do a very quick overview on the thing that we are going to cover under this topic. So similarly, like what we discussed previously, so we have topic 3.1 bivariate data, which is correlated to topic 4.1 time series data. So similarly, for topic 4.2 loans, investment and annuities, it will be correlated to topic 3.2. So if you can recall, in topic 3.2, we learned how to model growth and decay in sequences. So we learn how to write recurrence relation. We also know how to identify some of the special sequences, for example, arithmetic sequences, geometric sequence, and also we have first order linear recurrence relation. So we are going to bring all this prior knowledge that we have learned previously and try to put into the situation where we need to deal with finance. So it's just basically using our prior knowledge in sequences to model what happened to money in an account. So it's not limited to like investment account, but we also talk about loans. All right. So some of the contents that will be covered in this topic will be, for example, for today's lesson, we are going to talk about the basic thing that you need to know about financial mathematics first. So which is simple interest versus compound interest. So what is the difference between these two type of interest generated from an account? Then after that, on Thursday lesson, we are going to talk about effective annual interest rate. So this might be something new to you, but yeah, no worries about that for now. Okay, effective annual interest rate. Okay, so after coming back from the semester break, we'll be looking into the deeper part. So we are going to look at the loans. Right, so it's like the reducing balance of loans. Then after that, we move on to investment. So this investment is like you have a certain initial deposit. Then after that, you will put in like payment regularly. Then after that, of course, we have annuities as well. And under annuities, you also need to learn about perpetuity. Then in this situation, we have some special cases which you have different frequency. So different frequency as if the compounding period and your payment period are different. So yeah, these are something that we are going to deal with as well. Then last but not least, in the glossary of your handout in your syllabus, you also need to learn about depreciation. So of course, this thing is not specifically stated in your syllabus, but that will be something that is important that you will need to know. So now let's look at today's learning outcome. So for today, we are going to differentiate the difference between simple interest and compound interest. So especially for the part compound interest is the one that is the more important in our syllabus. So you are going to use the recurrence relation to model the compound interest loans or investment, then also to see what is the effect on the interest rate and also the number of compounding periods on the future value that you have in the account. Alright, so let's start our lesson today. Alright, there are some terminology that I would like to put in place first before we move on discussing the difference between simple and compound interest. So to make sure that every one of us are on the same page, that you won't be lost when you listen to some new words later. Alright, so we have the bank here. So normally when we go to bank, then you want to save your money, you want to do investment, or either you want to borrow an amount of money from the bank. So the initial or the starting value that we invest in a bank or we borrow from the bank is known as the principal. So for example, today you bring $5,000 and save in a bank. So the $5,000 is the principal. All right. So when you put in $5,000 in the bank, then you are expected to get interest, right? So this is why we are saving. Of course, for safety purpose, then if you try to put your money inside the bank, then you will get interest as well. So when money is borrowed or invested, interest is paid. So of course, we talk about investment, then which means you get more money lah. If we talk about borrow, then which means that you need to pay extra money because the loans that you are borrowing is going to generate interest as well. So the interest is calculated based on an agreed rate, which is called as the interest rate. So normally this rate will be given in a form of annually, so which means normally you will see some words that's like PA. So PA means per annum, or in another words, the yearly interest rate. All right. Okay. So now when we try to put in the amount, right, we also have this agreed length of time that the interest will be paid. So this is much more obvious in a way where fixed deposit is like an amount of money that you try to put into the bank, then you need to leave it for a certain period of time, then after that you will get a certain interest based on the interest rate. So in that case, if let's say you the agreement is that you need to leave your money inside the bank like for 5 years, then which means that will be your agreed length of time. So this agreed length of time is known as the period. All right, so that's the time that both the customer and the bank agree on that the interest will be paid. So that's the idea. So now remember all these keywords, then now we are going to look at the difference between simple interest and also compound interest. All right, in finance, normally there are two ways that we can calculate interest. So the first one is called as simple interest, and the second one is called as compound interest. So now we are looking at what is the difference between these two type of interest. So the first one, when you look at the word simple, so which means that interest is only paid on the principal only. Okay, so which means that if there's no change in the principal, the interest generated at each time will be the same. All right, so just remember simple interest only paid on the principal. Compound interest, on the other hand, the interest is paid not only on the principal, but then it's also on the accumulated interest that you generate from the previous time. Okay, so it looks like a little bit confusing here, but no worry, we are going to put these two different type of interest into the same case by looking at this simple illustration. So we have these two people, which is Mr. A and also Mrs. B. So both of them deposited 10,000 as principal into a bank as an investment. So you can see that both investment give them a return or give them an interest rate of 5% per annum. But for Mr. A, it's going to be a simple interest, and for Mrs. B, it's going to be a compound interest compounded annually. So now we'll be looking at how's the progress for this investment and to see whether is there any difference between the total amount of money that you have in the account after 4 years. So now let's start with Mr. A first. So we remember that for simple interest, the interest is only calculated based on the principal only. So now Mr. A deposited a principal of 10,000, and in his account, he has a total amount of money of 10,000. So after 1 year, the principal is still 10,000, right? But after 1 year, there are some interest will be generated based on this principal, which is going to be 10,000 multiply 0.05 or multiply the 5,000 here. So multiply 0.05 and you'll be able to get 500. So which means that this principal has earned Mr. A 500 of interest. So now in Mr. A's account, he has a total of money of 10,500. All right, moving onwards in the second year, the principal of Mr. A is still 10,000. Am I right? Because the 5,000, the 500 that he earned is the interest, is not the principal. And the interest for simple interest is only charged on the principal only. So now again, he will generate another 500 interest after another year, which is at the end of the second year. So now in his account, he have a total of 11,000, right? So plus another 500. Then moving onwards, now you can try to foresee for third year, the same thing. The principal is still the same, which is 10,000, and generate interest will still be the same, which is 500, and the total here will become 11,500. So after 4 years, at the end of the 4 years, then the same thing, principal is still 10,000 because Mr. A is not adding any money, right? So the interest generated is still 500, and then at the end, he has an amount of 12,000. So what you can see here is that for simple interest, right, the interest rate earned is actually constant over the time. So as long as you didn't add in any money deposit, you didn't add in any money as principal, the interest generated over the year will be just the same. Okay, so now let's try to look at Mrs. B. So this amount of money is compounded annually, so it's a compound interest. So same thing, she deposited a principal of 10,000, and in his account he has a total of 10,000. So after 1 year, this 10,000 of principal will again generated 5% of interest, right? So that's why it's the same with Mr. A. So he has 5,000. Sorry, 500 as the interest. So now the total amount of money that she has is going to be 10,500. Okay, now moving onwards in the second year. So the principal is not changed, am I right? It's still 10,000. Okay, but then remember the interest rate that Mrs. B will get is on the principal and also the accumulated interest. So now how is this amount of interest is calculated is based on the total amount of money that she has, because this is the money that the principal plus the accumulated interest, am I right? So it will become 10,500 multiplied 0.05, and that will generated an interest of 525. Why does it become more? Because now this interest is generated on this amount of money, which is 500 more than the previous principal. Am I right? So now adding in this new interest, and in Mrs. B account, she has a total money of 11,025, right? So now you can see the difference already. For she is having like $25 more than Mr. A, because the principal, or so called like the money that the interest is generated, is actually more than Mr. A. So now again, moving forward to the third year. So the principal is not changed as well. So Mrs. B didn't add in any money. But then the interest rate generated here is going to be on the principal plus the accumulated interest, which is the total amount here. So it will become $11,025 multiply 0.05. And from that, you'll be able to get 511. So you realize that this number become bigger and bigger because the amount that you are calculating your interest is getting larger and larger as well. So this amount plus this amount then give you the total amount in the account, which is 11,576. So moving onwards, at the end of the fourth year, the principal doesn't change as well, but the interest rate again is calculated on the principal and also the accumulated interest, which is this value. So this value multiplies 0.05 and you'll be able to get 579. So from there, now Mrs. B has an total amount of $12,155 in the account. So you can see that for Mrs. B, interest earned is increasing over the time. All right. So now when we try to compare the total amount of money of Mr. A and Mrs. B having in their account, right, you can see that compound interest will actually generate more interest when you try to compare to a simple interest. So as a result, you can see that Mrs. B is having more compared to Mr. A in the account after 4 years. All right, so if let's say we are doing like a saving investment, then you will want to opt for compound interest because that will eventually give you more interest after a certain period of time. All right, okay, so yeah, for example here, like 5%, 5% is just the same, but one simple, one compound, then the outcome is different. So now let's try to plot this into a graph, then let's see what happened. Okay, so you can see that for this part, right, you will started off with, this is the 0, so which means this is like the time, and this is the total amount of money that you are having in the bank. So you can see that we started off with a value of 10,000 here. Then after that, when you move on, right, then in the first year, second year, third year, fourth year, then you can see that there's an increment. Then for here, then you get like 10,500. So 11,000, 11,500, then after that 12,000. So you can see all the increment is like a constant one, because for every year you increase, like 500, every year increase 500, and so on. So this graph for simple interest will give you a linear pattern. Whereas for this part, what you can see is that the same thing, we try to put in like the total and then the time. So this one, Mrs. B also started off with 10,000 of principal. Then after 1 year, after 2 year, after 3 year, after 4 year. So what you can see that for the first one, you increase like 500. Then after that, second one, you will increase slightly more than the second one, then slightly more than the second one, and the fourth one. So, okay, I think I need to draw first because we do not have the numbers, right? Okay, so which means that what happened is you will get like a curve shape thing. So why is that so? Because you can imagine that for this part, you increase like for 500. So after 1 year, you increase like more than 500. You can see the increment become bigger. Then from here to here, another larger increment. From here to here, another larger increment. So you can see that the increment is getting more and more. So this graph for compound interest will show you an exponential pattern. Okay, so when reaching here, right, then you should be able to know that you will be dealing with the part where we learn about arithmetic sequence and export and also geometric sequence of, because linear graph is just AP. Exponential graph is like GP. So now let's try to find out the pattern that we are having. So in this case, we try to use the account. Okay, in the account for 0 year, in the end of the 0 year, then you have 10,000. Then after that, A1. At the end of the first year, then you have 10500. So I'm just copy down the total amount of money here, yeah. So 11,000, A3, then you have 11,500. Then after that, A4, then you have 12,000. Okay, so what you can see here is that the total amount in the account actually having a common difference, if you can realize. So from 10,000 until 10,500 is like plus 500. So moving on again, plus another 500 and so on. So this common difference is actually caused by the constant interest that we are having, because the simple interest is always calculated based on the principal only. So that's why you have a constant interest, and that's the amount of money that you add in after each year. So that's why this forms an arithmetic sequence. Okay, so which means if let's say we want to try to write it in a recurrence relation, right, then what you are having is actually your n plus 1 will be equal to your previous amount of money in the account, you plus 500 for each of the year. So you started off with A0 equals to 10,000. Alright, so that's the idea. So the same thing, how about for the second one? So it started off with A0 is equal to 10,000. Then moving onwards, your A1 is the same, which is 10500. So A2, just now the value is 11025. A3, 11576. Sorry for that. A4, we have 12155. So you can see that for this case, you doesn't have a common difference because the amount you're trying to add here is like 500, 525, 551, 579. But what you can realize here is that they have a common ratio here, because how are you getting all this value is actually multiplying 1.05 multiplying 1.05. And the 1.05 is the result of the initial value plus the interest rate. So which means that what you are having here is the total amount in the account has a common ratio. Okay, so you can try out with your calculator lah. You should get like, when you try to use A1 divide by A0, then you will be able to get 1.05. Same thing moving onwards, multiplying 1.05, multiplying 1.05. So this shows that we have a common ratio here, which is equal to 1 plus R. So the R here is the interest rate, which is 5%. Change it into decimal, which is 0.05. So this will forms a geometric sequence. So that's why the pattern that you're having just now is like an exponential one. So same thing here, we also can write a recurrence relation for that. So the account of money in the n plus 1 year will be equal to the n year and then multiply 1.05. Alright, and the A0 here is also 10,000. Alright, so that's the idea. I hope that by using this simple illustration, then you'll be able to see the difference between the simple interest and also the compound interest. And now we'll be doing some question about simple interest, then moving forward with compound interest. Alright, so we'll be starting off with a simple interest by using this example. So you can see that I'll try to explain by using this example before telling you the formula, because I hope that you can understand how this formula come from. At the same time, you are solving it by using your common sense rather than memorizing the formula only. But then if let's say you have difficulties to understand it, then of course formula is something that will be helpful because you can just use it without understanding why, right? But then yeah, same thing, I'll encourage you to understand why you are doing so. And this formula will be given in your real exams as well. Okay, so question 1. How much interest would be earned in 4 years on an investment of $5,000 at 6% per annum simple interest? So what amount will this investment grow to? So we know that for simple interest, your interest is always calculated based on the principal only. So which means for us to get our interest, we try to use I here. So to get our interest, you will be using your principal and then multiplying the interest rate, which is 0.06, right? So then you get the interest for 1 year. So the question asks how much interest will be earned in 4 years. So which means this value, you are going to earn it for 4 years, right? You can straight away multiply by 4 because you know that the interest generated each year will just be the same because it's all calculated based on the principal of 5,000. So that's why you will be using 5,000 multiply 0.06 multiply 4 years. Then from here, then you will be able to get a value of 1,200. All right, I think that's very straightforward, right? So which means that in 4 years, the investment will earn a total interest of 1,200. So what amount will this investment grow to? So which means that he's asking you like what is the amount of money that you have in your account now? So which means it will be equal to 5,000 and then plus 1,200 which you earn as an interest. So which means at the end you have a total money of 6,200 in the account. All right, just by doing that. Okay, so now from what we have done in this question, we try to generalize a formula here. So for simple interest only. So you can see that how interest is generated is by using the principal multiplying the interest rate, right? So the interest rate, we try to use a big R here and then multiply the number of years here. So because this is per annum, so which means how many annum that you have actually gone through is like 4 years. So that's why it's like 4. So we use the unit like T here. So I will be equal to PRT. Then how are you going to get the amount of money in your account? Then you are using your principal to plus your interest. So this is the formula that we'll be using. So I stands for the interest. Okay, so the interest. P stand for the principal. So which means your starting amount of the money that you put in the bank. R here is the interest rate. So always remember that we are trying to talk about per annum here. So if you are putting this per annum, then make sure that the T that you are doing is like number of year as well. So make sure your R will always be in decimal. All right. Then T is like the time here. So normally we talk about like how many times, which mean in year. Okay, because we are using per annum. So you must make sure that the unit of R and T must be aligned to each other lah. Then the A here, we talk about the total amount of money that you have in your account. Okay, so let me try to explain this thing in like the unit as well. So you can see, right, I equal to PRT. So P, we talk about principal is like money, right? Then after that, for the rate of interest, we talk about like what is the rate that you get per your time. So the time here, we talk about the year. So the time period here is like a year as well. So at the end, when you multiply them and what are you getting at the end is like year and year, they eliminate each other. So that's why the interest that you are getting is in a unit for dollar as well. So that's why you know that this formula is correct. because in maths we must, I mean, for example, you know that area is like cm square because it's like cm multiply cm. So it's the same thing over here. Rate, we talk about like how much changes per year. So you must make sure that these two unit must be the same law. So if let's say you are given like months and also you are given the interest rate per annum, but the time here you are saying like 24 months, then you need to change it to 4 years as well. Sorry, 24 months, then you need to change it to 2 years as well. So that's the idea. Okay. So now the same thing, we'll be doing a similar question, but now maybe you try to use the formula. So, but at the same time, I hope that you understand it from the first question, how this formula comes from. So now let's continue with question 2. So Sasha invests 4,000 in an account earning 5.6% per annum simple interest. Okay, how much interest will she earn in 3 years and 6 months? So the same thing lah. So for part A, so how are we getting the interest is by using the principal, right? So the principal is 4,000. So 4,000 will generate an interest of 5.6% per annum. So multiply 0.056. All right, and for 3 years and 6 months. So 3 years and 6 months is how many year? So remember that it must be always aligned to the interest rate. So the interest rate give us per annum. So which means the time period that you should give here is in year as well. So 3 years and 6 months, which means it's going to be 3.5 years. So multiply 3.5. All right, so from here, then you'll be able to get $784. Okay, moving onwards, B. What amount of money will the investment grow to in 3 years and 6 months? So which means the total amount of money is the principal and then plus the interest. So which is 784. So from here, we'll be able to get that Sasha is having like $4,784 in her investment now. Okay, so let's move on to number 3. All right, what annual rate of simple interest will an investment of 8,000 earn 3,600 interest in 6 years? Okay, so in this case, you can try to use the symbol that we have used previously and we try to denote it, then it will be easier for your solving. So we know that the investment of 8,000 earn 3,600 of interest in 6 years. So which means in this case, the principal is 8,000, right? After that, moving onwards, earns 3,600 interest. So which means I here is 3,600. So in 6 years, which means that the time period that we are talking here is like 6 years. And the question asks, what is the simple interest rate annually? So what is our R? All right, then now what do we need to do is to use the formula lah. So in this case, is if like the case for solving one, then it will be easier that you can straight away use the formula. So I will be equal to PRT. So interest, we have 3,600. Principal is 8,000. Okay, so R is what we want to find. Then after that, T here is 6. So when you try to multiply this together and we try to put it to the other side, then we'll be able to get R will be equal to 3,600 divided by 48000. So from here, then you can get 0.075. So in this case, what are you having is in decimal, right? But the question asks the annual rate of simple interest, and normally we will be giving our interest rate in terms of percentage. So which means in this case, the annual rate of simple interest is going to be 7.5% per annum. All right, so that's the idea. I hope that you get what we are doing here. So question 4. All right, question 4. A simple interest arrangement of 5.4% per annum sees an initial investment grow to 11121.60 in 6 years. What was the initial investment? So in this case, the same thing, it will be easier that we try to shift all the information as a denotation in max. So which means that in this case, we are given this interest rate per annum. So which means our R here will be equal to 5.4 divided by 100. Okay, remember our R always in decimal. So in this case, we have 0.054. Then moving onwards, this initial amount of interest grow to this amount of money, right? So this is the total amount of money we have in the account. So 11121.60 is our A here. So you are given in 6 years, so the time period here is 6. And the question wants us to find the initial investment, which is the principal. Alright, so as it involves the total amount of money in the account, then which means that the formula that we will need here is A equals to P plus I. So the total amount in the account is the principal plus the interest generated. So we have the principal, then the interest generated, we do not have the value, right? So that's why we might need to change it by using the other formula. So which is, we know that interest is calculated based on the principal, multiply the interest rate and multiply the time. So this is the formula that we are going to use here. So the A here, we have 11121.60. P is the principal that we need to find. So R 0.054 and T is 6. So now we try to add them together. So we can get 11121.60 will be equal to P plus 0.324P. So these two you can plus together, right? So 1 plus 0.324, then we can get 1.324P will be equal to 11121.60. So from here, then we'll be able to get P is equal to 11121.60 divided by 1.324. And from here, we'll be able to get our principal as 8,400. So that is our initial investment. So if you want to write down again, then you can just put in the initial investment, because the question is saying the words initial investment, right? The question didn't tell us the principal. So initial investment is 8,400. So that's the answer for this question. Okay, so the last one before we move on to compound interest. All right, 5. An account is advertised as having 7.2% per annum interest and paying interest every fortnight. So what amount would you have to invest in order to earn $150 per fortnight in the interest? All right, so same thing, we can try to write down our information here. So the first thing is you are given 7.2% per annum. So which means that our interest rate here is equal to 0.072 in terms of percent, in terms of decimal. Then after that, you want to find out how many money that you need to invest in order to earn $150. So which means $150 is your interest that you want to earn. Then after that, per fortnight. So which means that what is our time period here? So remember, if our interest rate is given per annum, then which means that the time period here should be in the unit of year as well. So per fortnight, how can we change it into year? So you can imagine like 1 year, how many weeks that we are having. So this one is important. So remember that you don't do like 1 month equals to 4 weeks. Then after that, you multiply 12 months, because you know some of the months might have. So you see, 1 month is actually having 30 to 31 days. So which means that when you try to divide by 4 weeks, then actually you have extra day. So 1 year is actually having more than 48 weeks. So this is something that you might need to remember. So 1 year is having 52 weeks. Okay, so which means that if we talk about fortnight meaning 2 weeks once, right? So which means that for 1 year, you have 26 fortnight. Okay, because 52 weeks you divide by 2, right? Because 2 weeks once. So which means that if let's say we want to change 1 fortnight into a year, then it will be 1/26 year. All right, that's the idea. I hope that you get what we are doing here. So if let's say you are doing weekly, then it will be 1/52 year. So it's the same thing, which means if you are doing like monthly, then it will be 1/12. If you are doing quarterly, then it will be 1/4. If you are doing like fortnightly, then it will be 1/26. Because in 1 year, you have 26 fortnight. So which means 1 fortnight, you have 1/26 years. So that's the idea. So now we want to find out what amount of money we need to invest. So the same thing, we are finding what is the principal here. So I will be equal to PRT. So we have our I, which is 150. So equal to principal is what we want to find, 0.072, the interest rate. The timeline here is 1/26. All right, so after we substitute, then after we multiply them together, then you'll be able to get 9/3250p equal to 150. So which means in this case, you will get P will be equal to, so just move this to the back, then become divide. So you'll be able to get 54166.76 dollars. So which means in this case, for you to get every 2 weeks, you get $150. You should be able to invest this amount of money into the account. Alright, so that's the idea. Okay, so now we move on to the next part, which we talk about compound interest. Alright, for compound interest, we'll be started off by using the idea for recurrence relation first, then after that, only we talk about the formula, because for compound interest, it's going to be slightly complicated when we compare to simple interest. Okay, so example 6, or 65,000 is invested at 7.5% per annum compounded yearly. Write down a recurrence relation that can be used to describe the value of the investment at the end of each year. Okay, so same thing, you need to get yourself familiar with the percentage kind of thing. If let's say for this amount of money, you are going to get an interest for 7.5%, then which means that for you to find out what's the total value in the investment account after you plus in the investment, will be straight away multiply 1.075. So same thing, we can try to let our AN, okay, in this case, we try to use account lah, so AN, let AN be the value of investment at the end of each year. Value of investment at the end of, in this case, end year. Okay, so the same thing, you can imagine that how are we going to get the next year? You will be using the current one to multiply 1.075, right? So which means that you earn 7.5%, you earn 0.075. So plus your initial value, then it will be plus 1. So that's why you straight away multiply 1.075, then you will be able to get the value. It's just similar like the case that we talked previously, like multiply 1.05, that one. So which means in this case, for each year, you will multiply 1.075, and that's the total value of money you are having in your account. Okay, so that's the idea. So if you were to write down some explanation for yourself, then it will be like this. So for year 0, so this is where you first started off, right? Then you have 65000. Okay, so remember, when you move on to the first year, then you can imagine that what you will be doing is, okay, if let's say this is your principal, you will be using your principal and then plus the money, which is 0.075, and then multiply your principal, right? How is this interest is calculated is by using 0.075 multiply your principal. So you can see these two things plus together, isn't it? You are getting 1.075p. So that's the idea. So after you get this value for the next year, again, you will be using this value, your new value, and then you are going to multiply the same ratio, right? So you get another 7.5% increment. So keep on increasing. So this one is like the recurrence relation that we are having here. And don't forget, every time when we are using recurrence relation, we will need to write down what is our A0. So in this case, because at the end of the end year, so which means we will always start with A0 is equal to 65000. Alright, so that's the idea. Okay, so we move on to the next one. Yeah, that's only the part for this question, because the question only wants us to write down the recurrence relation. Okay, 7. Alan inherits the 35,000 and decide to invest it in an account where he earns interest of 6.2% per annum compounded annually. So same thing, write down a recursive relation that can be used to describe the value of his investment at the end of each year. Then by using calculator, find out the value of investment after 7 years. So same thing, you start with year 0, right? Then you have 35000. So for the next year, you increase 6.2%. So which means it's going to be like this value, and then multiply another 1.062, right? Then you move on to the next year. So yeah, this is compound interest. So compound interest, the interest is generated based on both principal plus the interest accumulated. So that's why it's the whole value is going to multiply another 1.6 0.062. So that's why this form a geometric sequence. So from here, we are not going to repeat the same thing again. You can try to copy it again. It's exact the same sentence here. So the same thing, an plus 1 will be equal to an. Okay, multiply in this case is 1.062. Okay, because we are also calculating for n of each year. So the A0 here will be equal to 35000. So now we try to use our calculator to find out what's the value that we have at the end of the 7 years. So after 7 years, which means we try to find what is A7. So let's use our calculator to help us to do this. So again, just add list and spreadsheet, right? Then after that, menu, data, generate sequence. So in this case, we are using recurrence relation. So it's just un will be equal to un minus 1 multiply 1.062. Okay, not going to repeat this thing again. You should be very familiarized like how to generate this in your calculator already. So initial term 35000. All right, so at the end, just okay. Okay, then you'll be able to get all these values. So which means that after, or I mean at the end of the first year, you get this value. At the end of the second year, you get this value and so on. So just be mindful of the alphabet that you are having here. Because for this case, we are writing here as A0, right? So which means as you are finding A7, which means in your calculator, it should be A8. So the idea here is this is your initial amount. After 1 year is 2. After 2 years is 3. Okay, you get what I mean? So yeah, after 2 years is number 3. Then after 3 years is number 4. So you are finding after 7 years, so that should be number 8. So which means your answer here should be 53362.08. Okay, so that will be our answer. So A7 equal to 53326.08. So that's the idea. Of course, the other alternative is if let's say you do not want to have a different numbering in your calculator, right? Then the initial value, you should change it to 35000 multiply 1.062. Then you get your A1 equals to this. Then you straight away take the 7th place in the calculator. So if let's say if you are using 0 here, then which means that A7, you should take your A8 in your calculator. Alright, so try to use some time to actually understand what I mean here. Okay, so if you got any question, then feel free to come to us as well. Okay, so now we will be writing down a recursive rule for compound interest. So this one is very direct as well. It's the same thing that what we are dealing with just now. So every time you see that when we are writing down a recursive rule for compound interest, how are you getting the the future value in your account is by using the current value. You multiply the value of 1 plus r. Okay, then remember that you need to write your A0 so the A0 here will always be your principal. Okay, so it's the total amount of value at the end of the n year. Then after that, how do you calculate your r? The r will be always in decimal. Of course, the other alternative that you want to write, you can also do this as well. If let's say you are more familiar with this, you can also write down an is equal to an minus 1 and then multiply 1 plus r also. They are just the same thing. So which means that if let's say you don't want to write like this, you can also write like an will be equal to an minus 1 and multiply 1.062. They are just the exactly same thing. Okay, so now we will be moving on to the next part, which we talk about the formula. Alright, question 8. So this might get a little bit complicated, so make sure that you understand throughout the way. So 25,000 is invested for 4 years with an annual compound interest of 6%. So you see compound interest rate. So remember, you cannot use the formula for I equals to PRT here. So find the amount this account is worth and the interest earned at the end of the 4 year. So the different cases here is that if the compounding occurs either annually, quarterly, or daily. So that's the difference between these cases. So let's start with the easiest one, which we talk about annually first. Okay, so you can, the same thing, we do not have a formula here yet. So you try to imagine that how much of money you have after the first year. If let's say you invest 25,000 with a compound interest rate of 6%, then for your year 1, it will actually be equal to 25,000 and then multiply 1.06, right? So after 1 year or at the end of the first year, you will be able to get 25000 multiplied by 1.06. So from here, then you will be able to get your answer as 26500. Okay, so moving onwards, you'll realize that if you want to find your year two, what you'll be doing is you will do your 26500 multiply another 1.06, right? Because the interest rate is charged on the principal plus the accumulated interest. So in the other words, when you try to do this, it's actually just equal to 25000 multiply 1.06 multiply 1.06, which is equals to 25000 multiply 1.06 for 2 times, right? So square, then you'll be able to get your answer. So by using this idea, then you'll be able to understand that if you are finding at the end of the year 4, then what you'll be doing is you will take 25000 multiply 1.06 and you will be able to multiply it for 4 times. Okay, because the first time is after 1 year, after 2 year 2 times, after 3 times 3, then after 4 times is power 4. So from here, then we'll be able to get our answer, which is equal to 31561.92. Okay, I hope that you can see the pattern now. So if we want to find what is the interest earned, then we'll be using the other way around. So which means if we want to get the interest, then we use the total amount of money we have now and then minus off the principal that we saved 4 years before. So from here, then we'll be able to get the total amount of interest that I earn is 6561.92. So that's the idea. So I hope that you can see the difference now. So now we'll be looking at the second. Okay, again, maybe I try to further explain for this part. Why you cannot do it like how you do simple interest, like straight away times 4. So reason being is that every year your interest generated is different. So you cannot straight away take this multiply 0.06 and multiply 4 and you plus together with the principal. Because by using the first simple illustration, you already know that for compound interest, every year the interest generated is different because the interest will be generated based on the principal plus the accumulated interest. So that's why it forms a geometric sequence rather than an arithmetic sequence. So in this case, you can see that after each year, then you multiply 1.06, 1.06, 1.06, and so on. Okay, so that's the idea for part A. Okay, so part B, the only difference here is that you can see that the compounding occurs quarterly. So for each quarter, then you get 1 time of interest. For 1 quarter, you get 1 times of interest. So the difference here, okay, you can see, right, although the time period will be the same, but at the end, the answer will be different because of the compounding here actually occurs much more frequently. Okay, so let's try to imagine. In this case, we try to use Q1. Okay, so for the first quarter, what happened here is that you also have the same amount of principal, right? But then it's not going to be 1.06 because this is the interest rate for annually. So if let's say it's quarterly, then which means that this number has to be divided by 4. So you get the compound interest per quarter. So multiplied by, so same thing, this point we use 1 plus 0.06. So this will become 1 plus 0.06 and then over 4. So that's the idea, then you get your answer. So the same thing by using the idea for compound interest, when you are getting your Q2, right, then you'll be using this value. So this is the whole value, the total value that you have in your account after the first quarter. So you'll be using this whole value, then you multiply another ratio, right? So again, another 1 plus 0.06 over 4. So which means if I'm able to get 0.06 over 4 give me 0.015, then which means that this will give me 25000 multiply 1.012 square. So that's the idea. So when you move on, then you can imagine for Q3, then it will be equal to 25000. You will multiply 3 times already, 1.015 power 3. So now we are talking about at the end of the 4 year. So after 4 years, actually how many quarter you have actually go through? So each year you have 4 quarters. So which means 4 year you have 4 years you have 16 quarter. So we are finding Q 16. So in this case, then it will be equal to 25000 multiply 1.015 to the power of 16. So at the end, we'll be able to get our answer 31724.64. So what you can realize here is that this value will be slightly higher than this one. Reason being is because you have more compounding. So when your interest is compounded more frequently, right, you can imagine that, okay, you can imagine in this way. So yeah, later I'm going to erase this so you can just listen. So this is the period for 4 year. This is the period for 4 year. So every time when you are doing the yearly, right, then you are counting like one, then after 1 year, after 2 year, after 3 year, after 4 year lah. So you compound here, you compound here, you compound here, you compound here. So when you are compounding here, you are getting everything that you earn over here. When you are compounding here, you are getting everything that you earn throughout this period. When you are compounding here, you are getting all the period that you earn under this period. So now you imagine what happened here is that the period is still the same, which is 4 year, but now I'm compounding 4 times in a year, which means 1 quarter I compound 1 time. So it will become 1, 2, 3, 4. So you can imagine that previously, right, under this part, I only take once here, but now I'm compounding 1 time here, and when I compound here, I'm taking everything that's here. When I compound here, I'm taking everything that is here. When I compound here, I'm getting everything that is here. So even after 1 year, the value that you are having is going to be higher than this one as well because you already compounded 4 times. When you compare to this one, you only compounded 1 time. So that's the idea. I hope that you can see the relationship here. I mean, how come by using the same interest rate, but at the end of the 4 year, the value is different? It's because of the frequency that you are trying to compounding is actually much more. So that's why the interest generated will become more. Okay, so we move on. So for this part, your I, same thing, will be equal to 31724.64 minus of 25000. And from here, then you'll be able to get 6724.64. So you can see it's like 200 more than the previous one. Okay, last one, we have the daily one. So this one, you will need to think of it the same thing like how we do part B lah. Okay, so daily, we try to use D. So when we try to find D1, then which means it will be equal to 225,000 multiply 1 plus. So now this annual rate will need to change to daily rate. So for 1 year, we try to imagine that you have a 3,365 day. Okay, so that's for day one. So when you continue to day two, then you'll be using the same idea, right? So day two, it will be equal to 25000 multiply 1 plus. So let us try to calculate this value. Yeah, it's okay because you will get a very big decimal, I guess. 365, and you are going to square it, right? So which means now you are getting the value after 4 years. So 1 year you have 365 days. So when you multiply by 4 years, then you know that you are finding the day at the end. What is the amount of money you have at the end of the 1460 days? So which means you are going to do 25000 multiply 1 plus 0.06365 to the power of 1460. So that's the idea. So I'm sorry, actually all this I should put it as a prefix. So here, D1460 is like the small number here, but it's okay lah. So at the end here, you'll be able to get 31780.60. So I hope that by using the previous example, you can actually expect that this value is going to be bigger to the previous one as well because you compounded much more frequently as quarterly also. So I here will be equal to 31780.60 minus of the principal that you are having. Then from here, you can earn 6780.60. Okay, So now, using what we learned previously, we are going to generate a formula for this also. So this is slightly complicated, but yeah, you can also see this. So the total amount of money you have in your account will be equal to, normally how do we calculate that? You see that we always use our principal, right? So we started off with our P. Okay, so when we do quarterly and we do daily, what we are trying to do is 1 plus the R divide by how many period of time of you compounding in a year. So which means in this case, we'll be using multiply, okay, 1 plus. So R is the interest rate in this case, so which is the interest rate given in the question. Then after that, you will use it to divide by the number of, I'm using small r, yeah, small r, sorry for that. But it's the same thing lah. So interest rate small r and then divide by n. So n is how many compounding period you have in a year. So which means in this case, when you are doing quarterly, so which means 1 year you compound 4 times. If you are doing daily, then 1 year you compound 365 times. So that is the n here. And then to the power of, so you realize this is the value that you use, right? Okay, for example, how do you get 16? You are actually getting at the end of 4 years, you compounding 4 times each year. So that's why 4 times 4. How do you get 1460? You are compounding for 4 years and then each year you have 365 times. So you use 4 to multiply 365. So which means this is going to be how many times you compounded per year and multiply by how many years that you are calculating. Okay, so now let's try to write down the thing here. So the A here is the total amount of money. So always remember that this amount of money, we are talking about the principal plus the interest here. Okay, then after that, the P here is the principal. And then I is the interest. Okay, in this case, we actually do not have any I here lah, because you are just calculating inside already. So the R here, we have the interest rate. And remember, this one got to be per annum also. So this is for in decimal as well. Then the N is how many times that we are compounding it in a year. So number of times compounding per year. Then after that, our T here will be equal to the time in year. Okay, so let me try to use this formula again by using our previous example so that you understand it's actually not very hard. Okay, so again, look at this example. Then now, without doing all this, we can straight away get to this answer because this one is for your information, for your understanding. Okay, if you want to get the total amount of value after 4 years, then you will take the principal, which is 25000. Okay, and then 1 plus, so R is the interest rate, so which means the interest rate given by this question is 0.06, right? So 0.06 divide by N, how many times you compound in a year? So which means in this one, we do quarterly, so divide by 4. And then after that, the NT here, the same thing, how many times you compounded per year and how many year is 4 year. So that's why you get the exactly same thing like what we have here. Same thing moving forward for part C also, if you want to get A, then you'll be taking your principal and then multiply 1 plus the R here 0.06. How many times you compounded? Compounded daily, so 1 year you have 365 times. So N times T, so 365 times per year and you have 4 years. So at the end, you get the exactly same thing here. Alright, so that's the way at how you look at this formula. So similarly, if let's say your interest is compounded annually, then you can imagine that the N here will be 1 lor, because 1 time in a year, right? So that's why the formula will become much more easier, which is equals to A equals to P plus 1 plus R only, because you have R divided by 1, you get R. Then after that, the N here is 1, so that's why 2 power T only. So that's why, oh, sorry, there's no plus there. Okay, 1 P multiply. Yeah, let me try to put them together. P multiply 1 plus R okay, and then power t. So the same thing, you can try to look at this. So this is the formula that you are using. You see 1 plus r, 1 plus 0.06 to the power of 4. So that's the idea. Alright, so by having this, then now we move forward for the last two questions that we have for compound interest. Alright, question 9. At an 8% of annual compound interest with compounding every 6 months, how many years would it take for an initial investment of 2,500 to grow to 3,700? Okay, so same thing, let's try to denote all this in mathematical form. So we have 8% of annual compound interest, so which means our R here is equal to 0.08. Okay, then we move on for the second one, be compounding every 6 months. So which means that for 1 year, you compound 2 times. Okay, so remember you are not writing 6, so the n here is how many times you compounded in a year. So which means in this case, every 6 months compound 1 time, so which means 1 year you compound 2 times. And after that, at the end, how many years would it take for growth and investment of your principal is equal to 2,500, you will need to grow it until an amount. So your total amount is 3,700. Okay, so the question is asking how many years. So which means we are finding what is the t. So same thing, you can try to use the formula that we learned just now. So A is equal to P and then 1 plus R over N to the power of NT. So in this case, our A here is 3,700 equal to the P, the principal here, 2,500, then 1 plus the R here, 0.08, and then the N here, 2 times per year. So A N here, another 2, and then T is the one that we want to find. So now let's try to substitute all the numbers, try to solve all the values that we are having here. So in this case, we have 37200 equal to 2500. So 0.08 divided by 2 is 0.04. So that is 1.04 to the power of 2t. Okay, so we can use our calculator to help us to do this. So t will be equal to, so use the thing that we do in our calculator. So menu, okay, then, So we need to open another new page first. So we are adding a calculator. Okay, so I hope that you still remember how to use the ANSOLVE, and that is very important in our financial mathematics topic. So ANSOLVE, okay, so 3700 equal to 2500 multiply. So remember the multiply must put multiply 1.04 to the power of 2t. Okay, so after you put in everything, then comma, all right, then after that to find your t. So at the end, you'll be able to get all this. All right, so the comma is here. So the comma, okay, comma t. Then after that, you enter. So the calculator will straight away give you the answer here. So you have t equals to 4.9979. So in this case, after around 5 years. Okay, so that's the idea of solving this question. So yeah, it will take 5 years lah. It takes 5 years. Okay, question 10. Patrick invests 14,400 in an account earning interest that is compounded quarterly. Okay, so we can try to write down as well. So we have our principal is 14400. Compounded quarterly, meaning for each year you compounded 4 times. So in 6 years, the money grows to 18700. So which means in the time of 6 years, the money grow to a total amount of 18700. So what was the annual interest rate for the investment? So the question is finding what is the R. So the question wants us to answer in percentage, correct, to 1 decimal place. So same thing, use our formula just now. A equals to P and then 1 plus R over N and power of NT. Okay, so the A here, 18700 equal to principal 1 plus r is what we want to find, and then power 4, sorry, over 4, and then 4 multiplies 6. Okay, so now same thing, let's try to simplify a little bit for the power part maybe. 1 plus r over 4, and then we have 24. All right, then we can try to put this in our calculator as well. So now same thing. Okay, so and solve 18700 equal to 14400. Remember, multiply. Okay, then after that 1 plus r over 4. Okay, and after that to the power of 24. So comma, then you are finding your r, then enter. So you should be able to get your value under here. Okay, so can you see that? Yeah, so 0.043787. So 0.4379. So R will be equal to 0.04378. So question one is to answer in decimal and answer in percentage correct to one decimal place. So which means 1, 2, then we'll be able to get 4.4%. Okay, per annum. So that's the answer. All right, so try to understand the idea for how everything is come from, then make yourself familiarized with the formula, then you should be able to do the question. So these are the formula that will be given in your exam slot, so you can try to look at this. And yeah, I'm sorry that perhaps in the previous simple interest there, you can try to change it to small r and small t, so to make it align lah. All right, so that's the idea. Okay, so if let's say you got any question, then feel free to just ask me personally. So try to spend some time to do your question as well, so that you don't procrastinate and you can enjoy your semester break in next week. All right, so thank you.